Alright, in this video we're going to talk about the analog computer rack from the Miami Space Transit Planetarium. So, what this thing did, and I apologize for the sun flare, there you see Spitz Laboratories, Yorkland, Delaware, serial number 5. What this thing did is, this is what controlled the movement of the star projector. So it would control axis 1, 2, and 3. There's a black disc missing on axis 1, which is roll, pitch, and yaw, just like on an aircraft. And then you had another one, which was kind of like saying the master, what direction we're headed in, where are we in space. So the way this worked is, you had motors at the star projector, you had motors at the console, and the console operator had these knobs that they would turn, and it would move the dials that showed you what direction you were facing, how many degrees, latitude, longitude, your roll. It would show you that on a dial. So you would turn a knob, and depending how far you turn the knob, the pointer on that dial would move. As the pointer on the dial moved, this thing followed along. These right here would spin. And it would correct itself. Because basically what you're doing is introducing an error. So the console operator would turn a knob, it would move a little arrow. That was an indicator on a round dial that showed the number of degrees of latitude, longitude, of roll. And that would introduce an error which the machine would compensate for. And this analog computer here would cause the machine to move. Well, if I'm making sense here. But it's kind of like two stepper motors that are tied to each other. So you have two stepper motors tied to each other, and when you turn one, the other one turns on the other end. Well, what this did is it allowed somebody to turn a knob and introduce an error between those two stepper motors, and then the machine would compensate and line itself back up. So there was no ones or zeros going on here. It was all about differences in voltage. To an extent that if you actually went out to the star projector when this thing was running, and you grabbed a hold of the star projector and you pushed it, it would fight you and go back to where it was. So you were introducing a difference of errors. Now this ran on 400 cycle amplifiers, which are missing. I'm going to show you the backside in a second. Why? Because it's all aviation type stuff. I'm going to go ahead and pause this recording a second so I can flip the machine around. Alright, so here we have it. Turned it around. You can see in the back, computer rack, ooh, ominous. There's the computer. That's it. That is the computer. It's a series of motors. And it works kind of like stepper motors. And what it does is, it's looking for a difference between the motor that's on the star projector and the motor that's at the console, and then it is realigning the star projector to match what's at the console. It's just looking for a difference in voltages. That's all it's doing. So they're actually using, you see synchro transmitter, synchro motors, Selson motors. If you look up old World War II and Korean War technology, there's a lot of information on how these old Selson motor circuits worked. So this was just old military technology that they figured out how to repurpose to use to control a star projector, resulting in the first of its kind, and at one time the most advanced star projector that was made. Now there was a ton of wire in this. I remember hearing something like 12 miles of wire between these equipment racks and the console and the star projector, and everything was color coded. and labeled. It was an incredible feat of engineering to do this. So remember, there was no digital computer, there was no CAD. It was all people sitting there with slide rulers being geeks, using old school engineering practice to make this happen. Now down here at the bottom, there's some empty trays. That's where the Bogan amplifiers used to live that were used as the power supplies to make this whole thing work. But that right there was it. This is what controlled the entire star projector machinery. And let me tell you, it was crazy cutting edge technology for 1966. And this thing was in operation pretty much 363 days out of the year, because the museum only really closed for 2 days out of the year, except for when there was a hurricane or something. So this thing was in constant operation up until the day it was turned off. And the day it was shut off, it was the last of its kind in use in the world. And it was fully operational the day the key was turned off. Now from here I'm going to move on to the annual motion rack. So that's going to be another video, folks. Follow me along.